Okay, here is your study guide for your test that is on Friday. If you haven't gotten this paper, it should be in your yellow bin. So the first two questions ask us to decide whether the relation is a function and complete the chart. So looking at number one, looks like I have 2, -3, -5, 0, -7. So I can say, yes, this is a function because my x values do not repeat. And then since they are just random points, when I write my domain, it is a squiggly x such that, and then we list the numbers. So 2, -3, -5, 0, and -7. Close it with a squiggly. Range is just the same thing, but with my y values. So y such that 6, 9, 6 repeats again, so we're just going to write it once, 1, 0. Number 2. 2, we would use the vertical line test, since it is a graph, to see if it is a function or not. So I'm going to take my vertical line and move it through the graph, and I notice it hits in 2 places. That means this is not a function. So we would say no, this is not a function. Since there is a line, our domain and range, we're going to either use parentheses or brackets. Domain is asking me left and right, my x values. So how far to the left does this graph go? It looks like it stops here, and that is at -1, 2, 3, 4, -5. So I'm going to write down -5 is the farthest left, comma, what's the farthest right? So we still keep going. Farthest right would be at this point, which is +5. Now, my -5 gets a bracket. +5 is going to get a parenthesis because of this open circle. Range is up and down. So let's first do this. Let me delete this. Okay, so I'm first figuring out how far down does this graph go. Looks like that is the farthest down it goes, and that's at -1, -2, -3. It is still an open circle, so that means parenthesis, comma, how high does this graph go? Looks like up to here, which is 1, 2, 3, 4, 5. Since it is a closed circle, there is a point up there. 5 would get a bracket. Number 3, determine the quadratic function obtained from the parent function y equals x squared after the following transformations. And if this starts moving too fast, remember you are allowed to pause the video, rewind the video, or fast forward the video. This is totally up to you, whatever you need from this video. So my parent function is y equals x squared. So I'm going to make my y equals, leave some space, parentheses, x squared. The first transformation says stretch by 2. Stretch and compression go in the front. The next one is a reflection. Now a reflection is just a minus sign, which is also in the front, so it's a negative. And finally, I have a vertical shift down 7. Up and down goes at the very end. Down is -7. So we actually don't have anything inside our parentheses. Number 4, describe all the transformations of y equals 2/3 x minus 4 to the third plus 3 given the parent function y equals x to the third. We don't really care about the parent function in this case. All we care about is what's going on here. So my parent function is y equals x to the third. So I need to figure out what everything that does not have a yellow means. So I have this 2/3 that's in the front. That's where my stretch or compression goes. In this case, it is a compression because it's a fraction. So we could say compression by 2/3. I also have a -4 inside parentheses. So inside the parentheses, it's opposite. Minus really means I went to the right 4. And finally, I have the +3 at the end, and that tells me I went up 3. So now, with 5, 6, and 7, we are given a function, and we have to apply these transformations to it. So y equals f of x, and then the -2 is at the end. That means I'm moving each point down 2. So I'm going to take this first point, move down 2, down 2, down 2, and down 2. And then you just connect. Your new graph should have the same shape as your original graph. Number 6, we have a reflection, right? So that's my flip. And it's always over the x-axis. It's always over this. So I'm going to now take my points. I'm going to see, well, this first point is up 1, 2, 3, 4. So to flip it, I have to go down 4. 1, 2, 3, 4. There's my new point. This next point is up 1. So to flip it, I would go down 1. And again, next point, up 4. Go down 4. And then down 4. Connect your points. And it should have the same shape as your original. And number 7. +1 inside parentheses really means I'm going to the left 1. Take this first point, move it over to the left 1. Bottom point, left 1. Left 1, left 1. Connect your points. Make sure it has the same shape. And that's it for the graphing. Okay, number 8, this is where you'll need the calculator. First thing we want to do is get a picture of the graph. So, with your TI-84, make sure it's on. You'd hit y equals in the top left. And then we're just going to type in 3x squared. So 3x is by the green button. Squared is above the log. And you can hit graph to see what it's going to look like. So it's a U-shaped graph. Now, table of values, you would hit second, graph to get to the table. You're going to plot as many as you can. So I had 0, 0, I had a -1, 3, and a 1, 3. And then you connect them, making a U. Arrows at the end. Okay, because this is a line, everything's connected, domain left and right, this graph is going to keep going to the left and keep going to the right. So we would say the domain goes from -infinity to +infinity. Range is up and down. So the farthest down this graph goes is at the y value of 0, comma, the farthest up it goes Since we have the arrows, it's going up forever, so we would say infinity. Infinities always get parentheses, 0 gets the bracket because it's a number. Increasing and decreasing. If we had this imaginary line that goes through where the graph is at the bottom, so at that turning point, always start on the left. So on the left side of my graph is negative infinity. The right side of my graph is positive infinity. Negative numbers are on the left, positive numbers are on the right. So on the left, if I start here at the top and I trace it, my pencil would decrease. So I can say I am decreasing from the left side, negative infinity, all the way until I get to this bottom point. And that bottom point has an x value of 0. So now I have to figure out what's happening on the right side of the graph. Well, starting at my point at the bottom, keep tracing my graph. I will be increasing. So I'm increasing from 0 to positive infinity because I'm on the right side of the graph now. In behavior is just asking what direction are your arrows pointing. So where x is positive infinity, remember positive is to the right. So on the right side of my graph, I'm pointing up, positive infinity. As x approaches negative infinity, so on the left side, my left arrow still pointing up, positive infinity. Okay, let's take a look at number 9. Again, if this is moving too fast, just pause the video. If I go back to my calculator, I want to go back to y equals, hit clear, and then type in my new problem. So I have negative parentheses x minus 3, close your parentheses, squared plus 1. Hit graph. Okay, so we have an upside down U. Go second graph, get our table, and again we're going to plot as many points as possible. So you can scroll up, you can scroll down, get as many as possible. And then connect your points, making that upside down U, arrows at the end. Domain is asking left and right, so this graph will keep going to the left, so negative infinity, and it will keep going to the right, positive infinity. Range, up and down, this graph will be going down forever, so negative infinity, comma, the highest it will go is at a y value of 1. Gets a bracket. So increasing and decreasing, we find that point where it turns. Remember, the left side is negative infinity. Right side is positive infinity. So on the left, if I trace my graph, my pencil would be moving up. So I would be increasing from negative infinity, comma, all the way to this point. That point has an x value of 3. Remember, we only care about the x values. So then starting at 3, we keep tracing. We are decreasing. On the right side, positive infinity. So we are decreasing from 3 to infinity. End behavior asks about your arrows. So as x approaches positive infinity, positive numbers are on the right. So my right arrow pointing down, negative infinity. As x approaches negative infinity, which is to the left, left arrow still pointing down, negative infinity. Okay, number 10, find the inverse of the following function. So remember, with inverse, the first step is always to switch your x and y. So we'll say x equals 4y plus 7. Then we have to get y by itself. So I'm going to start by subtracting 7. X minus 7 are not like terms, so we just keep it as x minus 7 equals 4y. Divide everybody by 4. So you're left with x minus 7 over 4 equals y. That would be my inverse. Same thing with number 11 with the graph. Inverse, switch your x and y. So A is at the point 0, 1. If I was to switch that, I would be at the point 1, 0. And that's it. That's the inverse of point A. All right, last page. So number 12, select the correct domain. So domain is all the way to the left. So we are going to deal with a negative infinity. But as I trace, I notice there is a hole, and there is a hole at this point, 0, 1. Means the graph does not exist. So where x is 0, the graph does not have a domain. So we would have to say from negative infinity, comma, all the way to 0, takes care of that part. And then we would say from 0 to positive infinity. So the correct choice would be B. 13, over which interval is the graph decreasing? So if I got my line for my turning point, about right there, and I go to trace my graph, starting on the left, looks like I am decreasing. And since it's on the left, we would say we are decreasing from negative infinity down to this point here, which has an x value of negative 1. So between negative infinity and negative 1, we are decreasing. We are increasing from negative 1 to positive infinity. So choice D, that would be your increasing interval. Okay, 14, the parent graph y equals x to the third is translated 4 units right, down 1 unit. What's the equation? So my parent function, y equals, leave some space, x, parentheses, to the third. If we're going to the right 4, it would be a minus 4 inside, down 1, minus 1 at the end. And that's it. That's your equation. And finally, the last two. These are review from last unit. Yes, you will have a review section. So, which of the following is a solution? So absolute value, x plus 4 minus 5 equals 2. First step would be to add 5. So we get absolute value x plus 4 equals 7. I'm now going to split into my two problems. So I get x plus 4 to equal 7, and x plus 4 to equal negative 7. If I subtract 4, I get x to equal 3. Subtract 4, x equals negative 11. So both B and D are answers. On your test, you'll only have one answer. So you just circle whichever option you have. And 16, given f of x equals 1/3 x plus 1 and g of x equals 6x, what is f of g of x? Remember, open circle means open parentheses. So in the f function, I'm going to rewrite it 1/3, but instead of writing x, I'm going to change that to open parentheses and then plus 1. Now inside the parentheses is going the second function, g, so 6x. That's your setup. Remember, we always simplify, so if we distribute 1/3 times 6 gives me 2x plus 1. So D would be my answer. And that's your review. The answer key is also listed on Schoology, as well as answer keys to notes too. Remember, you are allowed to use your packet on the test, so make sure you have all the notes filled in and anything else that will help you be successful on the test.